A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com.
Hey, Herman and Corn. So we've talked before about local AI, and it certainly can be extremely useful, but it's also a challenging space at the moment in the sense that you might find a local model that you can quantize or run a smaller model, a 7B model, for example. For those who haven't done this before, quantization is basically taking a huge large language model and kind of squishing it down a bit so it can run on smaller power, lower powered hardware, the type of hardware you might have at home. And it works quite well, but the more ambitious things you try to do, whether that's having longer conversations or using it for code generation, which involves a lot of text output, or using it for images or videos in the context of generative AI, it becomes a lot more challenging to get something that can even do it. I can just about on a AMD GPU do some image generation using kind of lower end models, but trying to do image to image, image to video, coding, I've tried all of them. None really have worked very well. But I do see some changes on the horizon, and the thing I'm seeing at the moment is not something that is affordable yet for your average consumer, but there's two distinct trends that I'd like to talk about. The first is, we mentioned OpenClaw before, which has quickly become a really big phenomenon, and a lot of the people who are getting seriously into it are using Mac Minis. And we talked about before, and as a long-term Linux guy, I'm not overly familiar with Mac hardware, but I believe you mentioned that there's something specifically about what they put in their computers that makes them surprisingly appropriate and useful for generative AI. And the second trend I'm seeing at the moment, and this is led by NVIDIA, they're doing these giveaways. And, just in case, NVIDIA, do you want to take a chance on a guy with an AI generated podcast? I'm just kidding, because I would be number 100,000 on their list. They're major AI influencers. They're giving them these kind of boxes that are supercomputers on a desk, and the people are naturally overjoyed to get them because they would cost thousands of dollars off the shelf. But if you put aside the unviable economics at the moment for most people, the idea of not just having a local AI server that is like a big clunky thing. I'm looking at my own home server now. It's what you imagine a home server to be. It's a tower, and it's not a very compact thing. These products are really elegant. They're like little boxes. They have the form factor of a mini PC, a little bit bigger, kind of a cube, and the usage that these people are doing. I'm a desktop guy, as you know, but for most people who are using a laptop as their daily computer, they have their laptop open, they have a little box next to it, that's their local AI server, and I'm not sure if they're connecting to it over USB or over the network, or if that really matters, but they're connecting to it locally anyway, and it's driving their inference. And that is a pretty elegant solution. And of course, I think the most elegant solution of all is, why have two boxes when you can have one? If we can get to building hardware that is actually built for AI, so in other words, a laptop where you're stuffing really as much GPU into it as you possibly can, then I think most people would say that would be more ideal. Or you might have both in parallel. The kind of power users doing heavier stuff might still see value in having a home AI server, and your more average user just has an onboard one. And that would really actually shift AI seriously to the edge in a way that at the moment it kind of is happening, but really at the peripherals of the real dedicated community enthusiasts and people lucky enough to either get one of these things from NVIDIA, or they have the $10,000 to drop on it. But that's not most people. That's a very small amount. So my question, Herman and Corin, is as we progress in TPU, NPU manufacturing, do you think we're going to get to an era? And are there any products already like that? I'd love to kind of just get a stock of where we're at the moment, because I've seen a few products like this coming to market. You do still, of course, have those really big AI servers that are, essentially much larger, but I've seen some more compact models and prototypes that I think are much more interesting because they're a lot more pragmatic and realistic. And I'd love to talk about which one of those are on the market and what are we looking at in terms of the damage. Herman and Corin, over to you.
I was looking at my desk the other day and realized that for the last 3 years it has basically stayed the same, but the expectations we have for the little black boxes sitting on them have completely shifted. We used to just want our computers to open 100 Chrome tabs without catching fire. But now everyone wants to run a private assistant that can code, draw, and remember what they said 3 weeks ago. Today's prompt from Daniel is about that exact friction, specifically the emerging landscape of dedicated local AI hardware, and whether we are finally moving past the era where you need a liquid-cooled server in your closet just to run a decent large language model.
It is a fascinating moment because we are hitting a very specific wall with what I call the quantization compromise. Most listeners probably know that quantization is how we take these massive, multi-billion parameter models and squish them down so they fit into consumer hardware. But as Daniel pointed out, once you start doing that to a 7 billion parameter model just to make it fit on an old GPU, you start losing the very things that make AI useful. It gets forgetful, it hallucinates more often, and its ability to handle complex reasoning or long-form coding starts to degrade. By the way, today's episode is powered by Google Gemini 3 Flash, which is fitting since we are talking about the silicon that makes all this magic possible.
It really feels like the honeymoon phase of just being happy that the model talks back to us is over. We want utility now. And Daniel mentioned something that I think is the perfect jumping off point, the Mac Mini phenomenon. I've seen so many Linux diehards and Windows power users tucked away in forums admitting they just bought a Mac Mini specifically for AI. As a sloth, I appreciate anything that makes life easier without requiring me to compile custom kernels for 3 days. But what is actually happening under the hood of those little aluminum squares that makes them so good at this?
The secret sauce is something called Unified Memory Architecture, or UMA. In a traditional PC setup, you have your system RAM and your GPU VRAM. They are separate islands. If you want to run an AI model, the data has to travel across a relatively slow bridge called the PCIe bus from the CPU to the GPU. Think of it like a kitchen where the fridge is in the garage. Every time you need an ingredient, you have to walk all the way out there and back. With Apple Silicon, the CPU and the GPU are sitting at the same table eating from the same bowl of memory. There is no copying data back and forth. When an AI model needs 40 gigabytes of space to breathe, an Apple chip can just give it 40 gigabytes of the system's total memory instantly.
So, if I buy a Mac Mini with 64 gigabytes of RAM, the AI effectively sees a 64 gigabyte video card?
Almost exactly. On a Windows machine, if you want 64 gigabytes of VRAM, you're looking at buying multiple enterprise-grade GPUs that cost $5,000 each, but on a Mac, it is just a configuration option. This is why the M4 Mac Mini has become the darling of the local AI scene. We are seeing the M4 Pro version with 32 gigabytes of unified memory running 14 billion parameter models, like Llama 3.2, at nearly 35 tokens per second. To get that kind of speed and memory capacity on a traditional PC, you'd be spending twice as much and dealing with a power bill that looks like a mortgage payment.
But wait, if it's so much better, why isn't everyone doing it? Is there a ceiling to this unified approach? Like, does the CPU start fighting the GPU for that same bowl of memory when you're actually trying to work?
That's a great question, and yes, there is a contention issue. If you're trying to render a 4K video while your local LLM is trying to summarize a document, they are both tugging at that same memory bandwidth. On a PC with a dedicated GPU, they have their own lanes. But for the specific task of running a large model, the sheer speed of that unified pool, often over 400 gigabytes per second on the Max and Ultra chips, usually outweighs the downsides.
It's cheeky of Apple, honestly. They didn't even design these chips specifically for LLMs. They just happened to build an architecture that solves the exact bottleneck that transformers hate the most, which is memory bandwidth and capacity. I've seen the OpenClaw community absolutely losing their minds over this. They've optimized the software so heavily for Apple Silicon that it's become the default target. If you're a developer building a new local AI tool in 2026, you're making sure it runs on a Mac first.
And that brings us to NVIDIA's response, because they aren't just going to sit there and let Apple take the local AI crown. Daniel mentioned those supercomputers on a desk that influencers are getting, and that is a reference to the DGX Spark. It used to be called Project Digits in the rumors, but it's shipping now as the Spark. It's an elegant little cube, roughly the size of a toaster, but it's packing a GB100 Grace Blackwell superchip.
A toaster that costs $3,000 and probably produces enough heat to actually brown your bagels.
It's surprisingly efficient, actually. It has a 200-watt thermal design power, which is less than a high-end gaming GPU, but it comes with 128 gigabytes of LPDDR5X unified memory. NVIDIA realized that the separate GPU model is a bottleneck for the next generation of agents. The DGX Spark is their way of saying, fine, if you want unified memory, we will give you the most powerful ARM-based AI box on the planet. It's designed to be a local AI server that sits on your desk and connects to your laptop via a high-speed link.
Does it actually feel like a local computer, though? Or is it more like having a mini server that you have to SSH into? Because for most people, the moment you have to open a terminal to talk to your computer, the magic of a personal assistant kind of dies.
NVIDIA is trying to bridge that with a new software layer called EtherLink. It basically makes the Spark show up as a local resource in your OS. If you open a local AI-powered app on your thin and light laptop, it offloads the math to the Spark over a Thunderbolt 5 cable. You don't see a terminal, you just see your laptop suddenly getting 10 times smarter and staying cool to the touch. It's a compute tether model.
See, that's where it gets interesting for the average person. Most people don't want a server. They want their laptop to just be smart. Daniel asked about the era of dedicated AI hardware, and I feel like we're seeing a split. On one hand, you have the Pro route with the Mac Mini or the DGX Spark. On the other, you have these new dedicated AI accelerators that are finally hitting the consumer market. Have you looked at the Hilo 10 cards?
I have, and they are probably the most pragmatic answer to Daniel's question for someone who doesn't want to switch to Mac. The Hilo 10 is a dedicated AI accelerator on a tiny PCIe card. It costs about $199. It isn't a general-purpose GPU. It can't render Cyberpunk 2077, but it provides 26 TOPS, or tera operations per second, specifically for inference.
26 TOPS for $200 sounds like a steal compared to buying a whole new computer. But what does that actually look like in practice? If I plug that into my existing PC, can I run a coding assistant without my fans sounding like a jet engine?
Precisely. In benchmarks, the Hilo 10 can run a quantized Mistral 7 billion parameter model at about 28 tokens per second while drawing only 8 watts of power. That is the key. While your big NVIDIA 4090 is sucking down 400 watts to give you fast tokens, this little dedicated chip is doing it silently and efficiently. It's the difference between using a sledgehammer to crack a nut and using a nutcracker.
I love that. It's the applianceification of AI. But there's a catch with those, right? I remember you mentioning that the driver support is still a bit of a nightmare if you aren't a Linux wizard.
It is very much Linux first right now. If you are a Windows user, you are still mostly dependent on what the big three, Intel, AMD, and NVIDIA, give you in your laptop. Which leads us to the other big trend Daniel touched on, the integration of NPUs, or neural processing units, directly into the processor. We are finally seeing these become useful in 2026. Look at the AMD Ryzen AI 300 series.
Is that what's in the new framework laptops? I've been eyeing those because I like the idea of being able to swap out my AI chip in 2 years when it inevitably becomes obsolete.
Yes, the Framework Laptop 13 with the Ryzen AI 9HX370 has a built-in NPU that hits 50 tops. To put that in perspective, Microsoft's original requirement for a Copilot Plus PC was only 40 tops. So we are already well past that. What's cool about the framework setup is that you can actually run a model like Phi 3.5 Mini entirely on the NPU. It doesn't touch your CPU or your GPU. You can be rendering a video or playing a game, and your AI coding agent is still running in the background on its own dedicated slice of silicon.
That feels like the holy grail for the average user. I don't want to manage a server. I don't want to think about VRAM. I just want my computer to have a brain sector that handles the heavy lifting. But let's talk turkey here. If Daniel is looking at his AMD GPU right now and feeling frustrated, what is the actual stock of the market? If you had $1,000 today, where are you putting it?
If you want the best bang for your buck and you are okay with the Apple ecosystem, it is the M4 Mac Mini with 32 gigabytes of RAM. You can get that for around $1,200, and it is the current price to performance king for local LLMs under 15 billion parameters. It just works. The software is optimized and the memory bandwidth is there.
And if you're a never Mac person,
Then you look at the Ryzen AI 300 laptops like the Framework or the Asus models. You're looking at about $1,000 to $1,500. You get 50 tops of NPU performance, which is great for agentic tasks, basic coding assistance, and text generation. However, if you want to do what Daniel mentioned, like high-end image or video generation locally, you still need raw GPU power. An NPU is great for text, but it's not quite there yet for generating 48 frames per second of high-definition video.
so we're still in that awkward middle phase. It's like the early days of 3D graphics cards. Remember when you had to buy a separate 3DFX Voodoo card just to play Quake? We're kind of there with AI. You have your normal computer, and then you have this AI accelerator that makes the magic happen. Speaking of those early days, did you see that fun fact about the first dedicated AI chips? They were basically just modified crypto mining rigs that someone realized were decent at matrix multiplication. We've come so far from repurposed mining basements to these sleek Spark cubes.
It's true. We've gone from accidental AI hardware to bespoke AI hardware in record time. I'm curious, though, about the desk supercomputer trend. Is that actually going to trickle down to us mortals, or is it just for people with Founder in their Twitter bio?
The DGX Spark is the first attempt to make it a consumer product, but at $3,000, it's still a luxury item. But think about the trajectory. 2 years ago, the idea of having 128 gigabytes of high-speed memory on your desk for $3,000 was insane. Now, it's a product you can pre-order. I think by 2027, we will see sub-$500 AI boxes that you just plug into your router. They will act as a household brain. Your phone, your laptop, and your fridge will all just send requests to this one box in the hallway.
A home AI server sounds much more plausible than everyone having a massive GPU in their pocket. My phone gets hot enough just trying to navigate me to a coffee shop. I don't need it trying to simulate a conversation with a virtual philosopher. But what about the software side? Daniel mentioned OpenClaw. Does the hardware even matter if the software isn't there to utilize these weird new chips?
That is the big risk. Right now, the world runs on NVIDIA's CUDA. If you have an NVIDIA card, everything works. If you have an Apple chip, thanks to the massive effort of the community, most things work. If you buy a Halo 10 or a weird new NPU laptop, you are often waiting for the developers of tools like Ollama or LM Studio to add support for that specific silicon. That is why I tell people to be cautious with the compact prototypes Daniel mentioned. If it doesn't have a massive developer community behind it, it's just an expensive paperweight.
But how do we break that cycle? If everyone stays on NVIDIA because of CUDA, we never get the efficiency of these new NPUs. Is there a DirectX for AI coming that makes the hardware irrelevant to the software?
We're seeing it with things like ONNX Runtime and Apache TVM. They act as a translator. You run your AI app once, and these runtimes figure out how to talk to a Hilo chip, an AMD NPU, or an Apple Neural Engine. It's getting better, but we're still in the translation layer phase, where you lose about 10 to 15% of your performance just to make things compatible.
It's the classic chicken and egg problem. Developers won't optimize for the hardware until people buy it, and people won't buy the hardware until the software is optimized. Apple cheated by just having a huge built-in user base of developers who already had the hardware. But I think the AI giveaway trend NVIDIA is doing is a direct attempt to force their way into that elegant box market before Apple completely owns it.
It's smart marketing. They are showing people that AI hardware doesn't have to be clunky. It can be a beautiful piece of industrial design. And for the user who wants to run a 30 billion or 70 billion parameter model, which is where the real intelligence starts to happen, you need that memory. You can't run a 70 billion parameter model on a laptop NPU in 2026. You just can't. You need the 128 gigabytes of the DGX Spark or a high-end Mac Studio.
Let's talk about that 70 billion parameter threshold for a second. Why is that the magic number? Daniel's prompt mentions moving past the era of liquid-cooled servers, but if the real intelligence starts at 70B, aren't we still stuck needing massive power?
The 70B models are the ones that stop feeling like chatbots and start feeling like colleagues. They can handle complex logic without tripping over their own feet. The breakthrough is that we can now run those 70B models at a 4-bit quantization on a machine with 64 GB of RAM. 3 years ago, you needed 4 A100 GPUs, about $40,000 worth of hardware, to do that. Now you can do it on a Mac Studio or a DGX Spark. It's not that the models got smaller, it's that the desk got much, much bigger.
So the edge is actually split into two edges. You have the thin edge, which is your phone and laptop doing basic tasks, and the thick edge, which is this dedicated box on your desk. I think for someone like Daniel, who is technically literate and doing technology communications, that thick edge is where the fun stuff is. If you want to do meaningful automation and local agents that don't constantly screw up, you need the memory capacity that quantization currently destroys.
And that brings us back to Daniel's question about whether we'll see products like this already. We've talked about the Mac Mini, the DGX Spark, and the Hilo 10, but there's also the Orange Pi Kunpeng Pro and other SPCs or single-board computers coming out of Asia that have built-in NPUs. They are cheap, like $200, but again, the software stack is the hurdle. For a pragmatic buyer today, the answer is, if you want it to work right now, buy a Mac. If you want to be part of the future of Windows AI, get a Ryzen AI 300 laptop.
I'm still waiting for the day I can just buy an AI cartridge and slap it into the side of my laptop like a Game Boy. It feels like we're getting there. The Framework laptop is the closest thing to that dream. I love the idea that in 2028 I can just pull out my old NPU and slide in a new one that has 1,000 TOPS.
We might actually see that sooner than you think. There are already companies working on M.2 AI accelerators. These are the same slots your SSD uses. Imagine replacing your second hard drive with a dedicated AI processor. That is a very 2026 way to upgrade an old machine. Think about the millions of Office PCs sitting in basements right now. If you can turn a 5-year-old Dell Optiplex into a local AI powerhouse just by swapping the SSD for an AI module, that changes the economics of the whole industry.
That would be the ultimate weird prompt success story. Daniel, I think the stock of the market is currently Apple is winning on elegance and optimization, NVIDIA is trying to win on raw power and cool factor, and the rest of the industry is scrambling to put NPUs in everything so we stop calling it AI and just start calling it computing.
It's a transition period. We are moving from AI as a destination to AI as a layer, and the hardware is finally catching up to the ambition of the models. It is no longer just about benchmarks. It is about, can I run this coding agent for 8 hours without my office becoming a sauna?
As a sloth, not becoming a sauna is my primary hardware requirement. I think we've given a pretty good overview of the landscape. It's exciting, it's expensive, and it's a little bit messy, which is exactly how every great tech revolution starts. I mean, look at the transition from mainframe to PC. It wasn't one single day, it was a decade of weird, beige boxes and experimental expansion cards.
It really is. And for those looking for the practical takeaways from all this silicon talk, I'd say the first thing is to realize that the VRAM wall is the only wall that matters. If you are buying hardware for local AI in 2026, do not look at the clock speed. Do not look at the number of cores. Look at the memory bandwidth and the total capacity of memory that the AI can access. That is the difference between a model that works and a model that is a toy.
And don't get distracted by the cloud marketing. A lot of companies will try to sell you a dedicated AI PC that really just has a button that opens a web browser to their own cloud service. If it doesn't run when the Wi-Fi is off, it's not the hardware Daniel is asking about.
True local hardware is about sovereignty. It's about your data staying in that little box. And if you're a developer, target the unified memory architectures first. That's where the users are, and that's where the performance is. For the power users, if you have $1,200, that M4 Mac Mini is the current king. If you have $3,000 and want to feel like you're living in the future, the DGX Spark is calling your name.
Just make sure you have a sturdy desk for that Spark. It's small, but it's dense. And for the tinkerers, keep an eye on those PCIe accelerators like the Hilo 10. Once the drivers mature, those will be the voodoo cards of the AI era, giving a second life to millions of older PCs.
I'm looking forward to the 2027 episode where we talk about the AI boxes that cost $50 and come in cereal boxes. But for now, we are in the era of the elegant cube and the unified memory revolution. It's a good time to be an enthusiast, even if your wallet is currently crying.
It's always a good time to be an enthusiast when the hardware is this interesting. I think we've covered the spread. From the Mac Mini phenomenon to the NPU in your next laptop, the edge is getting a lot sharper.
Sharper and a lot more local, which I think is what we all want. No more waiting for a server in Northern Virginia to tell me how to write a Python script. I want the box on my desk to do it.
And with the hardware we're seeing shipped this quarter, that is finally becoming a reality for the average user, not just the supercomputer elite. It's democratizing the ability to have a private, high-speed intelligence without the subscription fees.
Well, I think that's our deep dive for today. Big thanks to Daniel for the prompt. It really forced us to look at the state of the union for AI silicon. We should probably wrap this up before I start trying to figure out how to solder an NPU onto my toaster.
Please don't. I don't think the world is ready for an AI-powered sloth toaster. Imagine the toaster trying to argue with you about the optimal level of crispiness based on your blood sugar levels.
Speak for yourself. My toast would be perfectly brown based on the humidity and my current mood. But anyway, thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thank you to Modal for providing the GPU credits that power the generation of this show. They make the thick edge look easy.
This has been My Weird Prompts. If you are enjoying our deep dives into the weird world of AI and hardware, a quick review on your favorite podcast app really helps us reach more people who are wondering why their computer is suddenly so much smarter.
We will see you in the next one. Take care.
Bye. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.